In this video, we're going to go over 10-3, areas of regular polygons. Now, before we get into it, I have a couple vocab words here that you need to write down. Radius of a regular polygon. The radius of a regular polygon is the distance from the center of the polygon to a vertex. So, this blue line here represents a radius. It goes from the center of the polygon, which, like the center of a circle, is in the middle. Okay? So, center of the polygon to a vertex. And then the apothem is the perpendicular distance from the center to a side. So this red line is an apothem because it is your perpendicular distance from that same center point perpendicular down to a side. Alright, so make sure you write these down in your notes. Pause the video. I'd recommend drawing a picture too so it makes a little more sense to you. So pause and write that down. Alright, so before we get into that, I kind of want to do a little side trip here. Alright, that's my attempt at drawing a regular polygon. Alright, here's our center. Now, say we divided this up into a bunch of little triangles. Alright, so we divide up into a bunch of little triangles, and then I drew an apothem coming down. Alright, so that's an apothem. Let's find the measures of angles 1, 2, and 3. Let's figure out how we would do this. Alright. Well, first of all, we have a hexagon, so we have 6 angles that meet at the center. Alright. All 6 of these angles, as well as any polygon, will always add up to 360 degrees. Alright, because these are not interior angles. Remember, these angles here are your interior angles. This is not an interior angle, so all of these add up to 360 degrees. Now, since we have 6 of them, simply divide that by 6. Alright? So 360 divided by 6 is 60. So that means that the measure of angle 1 equals 60 degrees. Alright, so to find these angles here, the whole angle here for number, not just 2, 2 is only half a part of it. So you just take 360 and divide it by how many angles you have there, which is also how many sides you have there. So it's really 360 divided by n will give you one of the angles. Alright? Now, your apothem bisects this angle. Alright, so since the measure of angle 1 is 60, and the apothem, which is what this solid blue line is right here running vertically, since it's a bisector and it bisects this angle, that means the measure of angle 2 is 30 degrees. Okay? Measure of angle 2 is 30 degrees. Now, to find the measure of angle 3, here's the easiest way to do it. These 6 triangles that were made here are all isosceles. Alright, they're all isosceles. So since we know this angle, we know that these two are going to be the same measure as well as all the way around. So you could use your formula for interior angle of a regular polygon. You could do that. Or since you already know this is 60, take 180 minus 60. Okay, so that's 120. And both of these have to be the same, so take that 120 and divide it by 2. 120 divided by 2 is 60 degrees again. Alright? So remember, to find angle 1, you simply take 360 divided by how many sides you have. The measure of angle 2 is half the measure of angle 1. Make sure you're writing all this down. Measure of angle 2 is half the measure of angle 1. And then the measure of angle 3, since these are isosceles triangles, and in our case equilateral, but I'm going to stick with isosceles because that's the general case. Since these are isosceles triangles, do 180 degrees minus the measure of angle 1, and whatever that number is, divide divide it by 2, and that's how you find the measure of angle 3. So as you can see here, when you drop the apothem down, this becomes a 30, 60, 90 triangle. So that trig we learned earlier is going to come back and help us out here. So you have to make sure you're strong in your trig. Right? You have to make sure you're strong in your trig, which is the sine, cosine, and tangents. Alright? Alright, so why do we need to know what an apothem is? Here's why. Your formula. Your formula for area of a regular polygon, alright, your area equals 1/2 your apothem length times your perimeter of your regular polygon. Alright, remember, perimeter is the distance all the way around. Alright, so let's go back to a hexagon in my feeble attempt at drawing. Not too bad. Alright, so here's our center. Let's divide this up. We know this is a right angle. And just like the last case, we know that this is going to give us, this is going to be 60, and this is going to be 30. Because from the last example, we know that a hexagon is going to give us a 30, 60, 90 triangle. But remember, all you'd have to do is to find the measure of this angle. Let's take 360, divide it by your number of sides, that gives you that angle. And then to find this angle, you just take whatever number that gives you and divide it by 2, and that gives you this angle. Alright? And then this angle plus 90, subtract from 180, and that'll give you the third angle. I'll give you a little hint though for 10-3 and only 10-3. For 10-3, this triangle is either going to be a 30, 60, 90 or 45, 45, 90. Alright? Now, say our perimeter, not our perimeter, the length of one of our sides is 3. Alright? And we want to find the area of the polygon. Well, it's 1/2 our apothem, which we don't know yet, but we can go ahead and figure out our perimeter. Since we have 6 sides and we know one side is 3, 6 times 3 is 18. So we know our perimeter is 18. Alright? We also know, oh, I forgot to mention this, but this is important. This apothem bisects the side. Okay? The apothem bisects the side. So since we know that the whole thing is 3, we know that from here to here is 1.5. Alright, we know it's 1.5. And since we have a 30, 60, 90 triangle, we're going to have to use our ratio that we learned. Why did I do that? 30, 60, 90, we know it's S times the square root of 3, and 2S. Alright? Remember, S is across from the 30. Well, our 1.5 is across from our 30. And then our apothem is across from our 60. So that means our apothem is S times the square root of 3 in the ratio. Since we know 1.5 is S, our length here is simply 1.5 times the square root of 3. Alright? So now we have our perimeter, we have our apothem, so now we can get to work finding our area. Alright, so 1.5 square root of 3. So let's go ahead and take half of the 18 and make it 9. So our area is going to be 9 times 1.5 times the square root of 3. So our area equals, you can punch this into your calculator, round to the nearest tenth, or round to the nearest whole number, and you would get that it is about 23. Alright, I don't have a calculator with me or I'd do it. But you can also leave it as simple as radical form, and that would be 13.5 times the square root of 3. Alright, so you can leave it in simplest radical form, or you can punch it into your calculator and round to the nearest whole number. I would prefer you leave it in simplest radical form because it's more accurate. Alright, it is more accurate. Alright? Alright, now I'm going to have you try a problem in your notes. Alright. Let's see, which one do I want you to do? Here we go. Alright, so pause the video, take a few moments, find the area of that polygon. Alright, so our area is 1/2 our apothem. Well, looky there, they gave it to us. Times our perimeter. We do not have our perimeter, so we need to find our perimeter. Again, since this is a hexagon, when you draw this down, you get a 30, 60, 90 triangle. And remember, your apothem, when you have a hexagon, your apothem here is across from your 60. So you know that's s times the square root of 3. So in this case, s is simply 4. But 4 is not the entire side length. It's only half of it. Alright? So if half of our side length is 4, what's the whole side length? Well, that's 8. Alright? So now, we have one side length is 8. 6 times 8 is what? Alright, good. 42. 6 times 8 is 42. So now, you simply plug in all of your numbers. You can half this. What does that have? 21. So 4 square root of 3 times 21. You can punch this into your calculator and do it that way. Or, wait, 6 times 8 is 48. What am I doing? 48. Half that to 24. Sorry about that. Now, you can either punch this into your calculator and round to the nearest whole number, or if you're doing it without a calculator like I am, 4 times 24 times the square root of 3. So 4, 24, 4 times 4 is 16, 4 times 2 is 8, 9. I would take 96 times the square root of 3 as a correct answer. Okay? Because I am a big fan of simplest radical form. So is the EOC. Alright? So if you learn to leave your answers now in simplest radical form, it'll help you down the road. Because if they ask you to convert this to a decimal, that means you'll have a calculator to do it with. So you can just punch that into the calculator at that point. But, like I said, I will always take simplest radical form as an answer, and I always prefer simplest radical form over decimals as answers. Alright? So let's look at one more problem, and then we're going to call this video finished. Say we had a square with an apothem of 5. Alright, this is a square. With an apothem of 5. Now, I know for this you could just extend it up, say, well, a side length is 10, 10 times 10, 100. Boom, we're finished. I don't want you to do this one this way. What I want you to do is do it as a regular polygon. Alright? So draw this over here. Now we have, if you were to draw this, all the triangles, we have 4 angles here. So to find a measure of one of them, we're going to take 360 divided by 4. That gives us 90. Alright? So we know that each one of these is 90 degrees. So each one of these is a right angle. Which means that this angle here, because the apothem bisects it, means this is 45 degrees, this is 45 degrees. So looky there, we have a 45, 45, 90 right triangle. Alright? We have a 45, 45, 90 right triangle. So that means that from here to here is also 5. Because remember, your ratio, if we have 45, 45, 90 triangle is S, S, S times the square root of 2. So both of our sides are S, our hypotenuse here is s times the square root of 2. So since the s times the square root of 2 is the hypotenuse, which is part of the diagonal, we don't need s times the square root of 2 for this problem. Here our apothem is 5, well it's also s in the ratio. This is s in the ratio. So half our side length is 5, making one side length 10. So now we can come back over here and plug into our formula. So A equals 1/2 the apothem, which is 5, times the perimeter, which is 4 times 10, so 40. All right, let's go ahead and half that for 20. So our area is 5 times 20, which is 100. All right, so it even works for squares, because a square is a regular polygon. And this formula works for every polygon. Alright? But again, you're going to have to be strong in your trig in order to do these. So make sure you brush up on your trig, because for 10-3, all of these will end up as either a 45-45-90 triangle or a 30-60-90 triangle. So you're going to need to know, why am I saying trig? You're going to need to know your ratios for your special triangles, okay? Later on, in like 10-7 or somewhere, I forget the exact number, they won't come out to 45-45-90 triangles, so that's when you'll need to know your trig. But for now, make sure you're strong in the two types of special triangles, 45-45-90 and 30-60-90. Remember, the ratio for a 30-60-90 is s times the square root of 3, and 2s. Alright? So this has been your 10-3 video, areas of regular polygons. You can watch it as many times as you need to. Make sure you're ready to work some problems tomorrow when you come to class. See you tomorrow.